Okay, so our directions are given a polynomial and one of its factors, we're supposed to find the remaining factors. Now, we can do this one of two ways. We could use synthetic division, or we could use long division. Now, I know you probably would like to use synthetic division because it seems to be a lot faster and we have to write a lot less. However, this polynomial and this factor's not in the synthetic form yet. So if we were to set it up with long division, it's actually perfect for long division because that 2x will go evenly into that 2x cubed. So if we were to set it up using long division, we'd start something like this. However, you probably still don't want to use long division because synthetic division is so much faster. So here's our long division, multiplying by x squared, and we have to subtract that. So we're writing down a lot of things, and we could continue that way. But let me show you how to solve this problem using synthetic division. Now, when we use synthetic division, we must have it in the form x minus a. Now notice we have a coefficient in front of that x, so it's not going to work. So we're going to need to manipulate that equation to put it in the form, that factor in the form x minus a. Now we can't just divide by 2, otherwise we change the value of what we're doing, but we can multiply the whole thing by a special 1 half over 1 half. Now notice I wrote the division problem in terms of a fraction so that I could do this. So multiplying the top by 1 half, I have x cubed plus 17 halves x squared plus 23 halves x minus 21, because 42 divided by 2 is 21. And then on the bottom, 2x divided by 2, or times 1 half, is just x plus 7 halves. Now, I haven't changed anything, I just multiplied by a 1, but now I have that factor in the right form. So now I'm going to go ahead and set up my synthetic division. I use the coefficients in my synthetic division. So I have a 1, a 17 halves, a 23 halves, and a negative 21. And that has to be a negative 7 halves because I want to take the opposite of a, and our a is 7 halves. Okay, so I bring down a 1, multiply by negative 7 halves, and I get negative 7 halves. Now, when I add those, I get 10 halves or just a 5. And I multiply again by negative 7 halves, and I have negative 35 halves. And I get a negative 12 halves, which is just the same as negative 6. I multiply again, I get a positive 42 halves, which is actually just a positive 21. And that is a 0, which I expect because I know that x plus 7 halves is a factor. But I want the other factors. I can use this part of my synthetic division. It gives me a depressed polynomial. That means if I were to multiply it by the given factor, I would get back to the original polynomial. But this is a depressed polynomial. This is another factor if you want to think about it. And we're going to see if we can get this factor down to even smaller factors. So I rewrite just using the coefficients. It's going to be 1 degree less. So it's 1x squared plus 5x minus 6. And then factoring that, which I can, that's factorable. That is just a plus 6 and a minus 1. So when I multiply, I get negative 1x and positive 6x, which gives me that 5x, and 6 and negative 1 gives me the 6. So if this weren't factorable, my factor would actually be a quadratic. But since it is, I have 2 more binomial factors, and those are the remaining factors.